Hi, my name is Tristan. Welcome to the channel. Please like and subscribe if you want to see more content. So this is going to be a first video in a series on BGP, which is the Border Gateway Protocol. It's quite a big topic, one that I'm still learning. Thought it'd be good to make a video series to go along with the website articles, so you can build your knowledge of BGP bit by bit. So what is BGP? BGP is Border Gateway Protocol. It's a routing protocol that's used to exchange information like RIP, OSPF, eIGRP. It's primarily used on the internet for the exchange of routing information, but in recent years it's begun to be used in internal networks too. BGP uses a concept of autonomous systems, an AS for short. It's a network that's independently managed by an ISP, corporation, government, whatever. BGP is used to exchange routes between these ASs, but is also used to exchange routes within an AS as well. When you're exchanging routes between ASs, it is known as external BGP or eBGP, and when you exchange routes within an AS, it's known as internal BGP or iBGP. Each AS has its own identifier. In this particular example, we've got 65,001 and 65,002 as the two AS numbers. These are from a private range. I'll go on to that in more detail in a later video. But for now, all you need to know is that in terms of the ASs. So what we're going to do is build up this small network between router A and router C to give you an example about how the routes can be exchanged between the two. So what we're going to do is build this network up. It's going to be router A, router C. They'll have a single point-to-point link between them. It will be a /30 network. We're then going to have a network on router A, which is sort of a pretend network to represent a local LAN there, and the same sort of thing on router C. This will give us something we can use to test our connections between the two. There's also this amber coloured number. This will be the router ID. We'll make it a loopback interface. That'll probably come into use later on, but that's essentially the router ID is something used by BGP to identify the router in any particular peering neighbour. Right, so let's get started. So what we're going to do on router A is we are going to configure the point-to-point link first. So that's the point-to-point link for router A. You can see the IP address 100.9, which is that end of it. We're enabling IP forwarding and we're adding it to port 3 untagged so it can use that link to router C. We then go on to router C. Same thing on that end. So at this point, we should be able to ping the interface on router C from the interface on router A. And there we go. So the next step is we're going to add the loopback interface we mentioned about. So on router A, there we go. So we're creating a VLAN, giving it an IP address, in this case 1.1.1.1 as a /32 single IP address, enabling loopback mode so the VLAN stays up. We're also enabling IP forwarding on it, not needed specifically at this point, but we will probably need that later on. Router C, same thing. But on this side, 1.1.1.3. We now need to create our pretend example network. So the way we're going to do that is by creating a VLAN with an interface, and we're going to enable IP forwarding it and also turn on loopback mode to make that VLAN come up. You wouldn't normally need to do that in production because the network would stay up by dint of it having something downstream. We're putting the IP address 10.1.0.1 on it as the gateway. It is a /24 network. I'm going to do the same thing on router C, but with a different network range. Create the VLAN, create the IP, enable IP forwarding, enable loopback mode. So those are all the steps required to get us to this. Okay, so we're now ready to enable BGP. So in our design, we had AS number 65001, 65002 on router A and router C respectively. So we're going to do those configurations first. So first thing we're going to do is set the AS number on router A as 65001. Going to set its router ID. You must do that. Each BGP router needs a router ID, and then we need to enable BGP. So now when you see this, you should see BGP is enabled, the router ID is set. Same thing on router C, except we're going to give it a different AS number of 65002, a different router ID of 1.1.1.3, and we are going to enable BGP. There we go. That's all good. So the next part we need to do is actually make these two routers talk to each other. So at the moment you can see there is no BGP neighbour. So router A doesn't know anything about router C, and router C does not know anything about router A. So we're going to create a neighbour first. So 192.168.100.10 being, as you remember, that is the other end of the link. We're on router A.10. And we're specifying it's a remote AS, so it knows it is eBGP. We're then going to configure the source interface for that neighbour. In this case, that is 192.168.100.9. So we're specifying essentially this is the source for that particular neighbour. Of course, in a real example, you could have more than one interface that's using BGP. Therefore, you need a way of identifying which neighbour is down which link. And finally, we want to enable that neighbour. So we're going to go on to router C now. Same thing in reverse essentially. So .9 being the other end of the link. We want to set the source interface, and we want to enable the neighbour. So we run show BGP neighbour. We can see established. So the BGP neighbour peer is up and running, which means they would then be able to exchange routes. There are different states of BGP adjacency. I'll go through these in a later video. Okay, so having BGP neighbour adjacency is all well and good, but we're not actually sending any routes between the two. So if we have a quick look at the route table on router A, we will see that we have 3 routes. Now these are D, meaning direct, meaning they're routes that are learnt by this router directly attached. So things like the loopback interface, the point-to-point link, and our local LAN. Now we want this route table to contain 10.2.0.0/24, which is the LAN at the other end of the link on router C. So to do that, you have to tell BGP how to advertise that, well, to advertise that route. So we'll do that. So first thing we're going to do is on router A, we're going to tell it to advertise its local network. And on router C, we're going to tell it to advertise its local route. So now, there we go. So it is now showing the route 10.2.0.0/24, which it has learnt from router C. And if we go on to router C, we can see this has learnt 10.1.0.0/24 from router A. We know that this is coming from BGP because it is saying BE, which means B for BGP and E for it being an externally learnt route. Okay, now we've got everything set up, we want to do a few tests just to prove what we've done works. So first thing I'm going to do is we're going to ping from router A to router C, and we're going to ping specifically from this interface to this interface. So that proves that link works. Now we know that link is working because otherwise any of the route advertisements, as it were, wouldn't have passed. So let's go the other side, have a quick go with that. So that's also working, pinging back the other way. So now what we actually want to do is see if from router A, can we ping the interface on router C. So from here, can we ping to here? Let's give it a go. Yes, we can. Great. Go to router C, do the reverse. So can we ping from the local to 10 network? And the answer is yes, we can. So we've been able to ping from here to here and vice versa because those routes have now been exchanged. So final test just to prove it. If we shut down the port, what we should find is that that route disappears. So if we do show IP route, you'll see now that that route has disappeared from the route table. So if we were to rerun the ping, so pinging from router A to router C, see it's now showing destination unreachable. Additionally, when you look at the neighbour, you'll see the state is still showing as established. After around 180 seconds, I believe that's the default timer, it will then go to idle state because at that point BGP has decided that neighbour is no longer there. And after about 180 seconds, we can now see it's now gone to state active from idle, which essentially shows it doesn't think that BGP neighbour is there anymore. So let's just re-enable that port. May then take a few moments before it decides that's available again. So now we can see it's changed to established. That shows the link has come back up again. So I hope you found that useful. The link to the website with the steps that I've taken today can be found in the description below. So that's all for today. Thank you for watching.